largest power of the graph. So in this case, Connor, there are 4 of them. There are 4 zeros. That also tells you the degree. The number of zeros correlates with the degree of your polynomial, so that would be 4. And then the last thing is the end behavior. The end behavior, there are 4 cases for your end behavior. And again, you're asked to do this without using the calculator. And there's only 4 options. So it's either odd and positive, odd and negative, which Connor said the power was 4, so those 2 options aren't valid. Or it's even and positive, even and negative. So this one is even. Is the leading coefficient positive or negative? So Connor, the leading coefficient, is that positive or negative? Positive. And that's the number in front of the first parenthesis. You could put a 1 in there, you could put a 1/2, you could put whatever number you want in there, but it has to be positive. So we have even and positive. The one right next to it has a negative sign in front. That's how you'd know it would be negative versus being positive. So when it's even and positive, can anybody describe the end behavior? Holly? Say it again?
W.
Yeah, it kind of looks like a W. So meaning you would say the left goes up and the right goes up. That's like our cheater way of saying end behavior. But both sides, left and right, and every graph has a left and a right. You always have to describe both. They both should go up. So the last thing then, so the left is up, the right is up, would be to try and make a little sketch using this information and the 8 graphs that you did on the previous page. And Holly said this should look like a W. So if you go to your end intercept, the end behavior means from that intercept, it should go up. So from those 2 last points, the graph should go up. It's not going to do anything beyond those because those are the last x-intercepts. And then you kind of have to play connect the dots. And it cannot be flat, so it has to probably go somewhere down below. Go through your x-intercept, play connect the dots to the next x-intercept, and then continue to go somewhere down below. We don't know how far, but it has to curve back to get to your next intercept. Now, I know we don't know these points down here. We don't know the point up there. We'll get those today using the calculator. But you're just asked to make a sketch. So making a sketch with those 4 points based off of the 8 graphs that you did on the previous page. So let's look at the one directly underneath it, just going through that one so you can see a different power. So we have a negative in front, and then x plus 2, x minus 1, x minus 4. So Holly said the zeros were really setting each of the parentheses equal to 0. So Melanie, if you do that, what are the zeros that you get from this one right here, right underneath?
-2, 0. 1, 0, 0, 0.
Yeah. And then Melanie, the degree would be 3. Now there are 3 zeros, 3 x's, the degree is 3. So now we're looking at odd, because 3 is odd, and there's a negative sign in front, so it's odd and negative. So Melanie, what do you know about graphs that are odd and negative in their end behavior?
The left side goes up and the right side goes down.
Nice, so the left side goes up, the right side goes down. So to graph this, plotting those 3 zeros, -2, +1, and 4, she said the left side goes up, the right side goes down. So that's using the end behavior of the graph. And then we're just going to try and connect the middle, knowing that there has to be curves in the middle. We also call those curves turns. So we have to turn to get to this point, or curve and turn to get to the other point. And again, it could go high, it could go low. We're not really worried about that right now. So left up, right down. Before we go to the other page, the last 2 questions on that other page on the front, they wanted you to decide the maximum number of turns of the graph. So if you look at this graph that I have above here, a turn is a curve. Will, how many curves are in that graph? first graph here? 3. So there are 3 curves here. How many x-intercepts do you have? 4. So you will have 1 less curve than you do x-intercepts because you have to be able to connect the points. So if you connect the dots, you really have 3 areas that you're going to have to curve to get to the next dot. So 4 intercepts means 3 curves. You're going to have 1 less curve there. So if you look at the one underneath of it, we have 3 x-intercepts, but you're only curving twice to connect all those x-intercepts. So this would have 2 turns or 2 curves of the graph. So kind of taking that then and looking at the other worksheet, this worksheet here. So for this worksheet, you were just asked to describe the end behavior. You didn't need to graph, you could have, but the goal was not to rely on the calculator and just to rely on one of these 4 options. And now I have 2 of the 4 filled out. So looking at the largest power, this is odd and positive. So that's really all the work you need, odd and positive. So odd and negative had the left go up and the right go down. Odd and positive, Julia, is going to have
Left go down, right go up.
right, the left go down and the right go up. So for the first one, because it's an odd power and it's positive, the left goes down and the right goes up. Matt, did you have your hand up? No. Okay, sorry. Oh, okay. All right. So I'm not totally crazy that I saw an arm somewhere. All right. Saw it out of the corner of my eye. So if you look at, let's see here. Well, number 6, that was the last one we didn't do. Right here, number 6, it's even because it's x squared, and it's negative. So Gavin, what do you know about even and negative graphs? Even and negative, they both go down. The left would go down and the right would go down. So those would be your 4 cases, and there are only 4 because you either have even or odd numbers, and numbers are either positive or negative. No other options. That's why it creates the 4 different cases of your graph. Questions? So at the bottom, it says to state the number of turns of the graph. So how many times does it curve or turn to go from one point to the next? And that's where you're relying on that largest power again. The degree tells you a lot about a graph. It tells you how many x-intercepts you have. It tells you the end behavior. It also tells you the number of turns that you'll have. So if the power is 5, how many turns would your graph have? How many times do you have to curve to get to the next point, Matt? 4. So this has 4 turns, or 4 curves. So there are 5 points that you have to connect, but you're going to turn 4 different times to connect those points. So Matt, for number 10, it's only x squared. So you would just have 1 turn. What kind of graph is x squared? What's it called when you have an x squared graph? Melanie?
Linear.
Ooh, so close. What's the next one after linear that we learned? Begins with a P. Parabola. So this one's a parabola. So if it's a parabola, we know it's either a U that goes up or a U that goes down. Those are the options that you have. It's 1 turn, 1 curve. Because the power's x squared, I would have 2 x-intercepts. To connect those 2 x-intercepts, I just need to curve once to get there. Questions? So today we're going to take the information about the end behavior, the information about the x-intercepts. We're going to see if we can plot a couple other points to get a more specific graph. And then we're also going to try and use the calculator to get us those highest and lowest points. So unfortunately, you could plot a whole bunch of points and try and get really close to the lowest point of the graph. But besides trying to pick a whole bunch of x values to get close to that lowest point, the calculator is going to help us actually find that lowest value, the exact value. So in your notes, we're going to start 5-8 today. We'll wrap up 5-8 tomorrow. Of course, we'll have a little word problem to do. And then on Friday, we will review for your Chapter 5 test, which is Monday. So in your packet, this should be, I think, the last page, second to last page of your packet. Again, if you have your calculator out, that'll help because we'll go and look at that and use it in a little bit. It says analyze graphs of polynomial functions at the top. And then it talks about these 4 words: zeros, factors, solutions, and intercepts. And those 4 words we will use pretty much through the rest of Algebra 2. You'll continue to use in honor string or pre-calc, and then you'll continue using calculus. They're interchangeable. They're all equivalent. They're synonyms of each other. Trying to use an English word there. So a zero is a factor, is a solution, is also an x-intercept. They all mean the same thing. You pretty much find them all the same way. It's just one might be written a little differently than the other. So it says we have this huge polynomial function, and this is the notation we used when we talked about polynomials. A sub n x to the n power plus a n minus 1 x to the n minus 1. And then it has all of the powers in between till it gets down to the first power and then just the number at the end, like constant value. So that's the standard form of a polynomial function. That just means your powers start big and they descend in order as you work through the equation. It says k is a real number, then the following statements are equivalent. So we're just saying a k, a 5, a 10, a negative 3, a negative 8. Just some kind of number, we're just calling it k. So, sorry. The first one says a 0, that would be our first term, which is the ones you just looked at. So it can be a 0 when we write it as x equals k. A 0 is a point on your graph. It's the x-intercept of your graph, which is another word down there. That's why they mean the same thing. So a 0 and an x-intercept are the same exact thing. The next one says it's a factor of the polynomial. So when it's equal to k, it's a 0, but when it's in parentheses, we call that a factor, which is exactly what you had on your page. You had factors, we then took them and found zeros. We plotted them as x-intercepts. It's all the same thing. A factor finds a 0. You use a factor to get a 0. It's a solution when it's equal to 0 and you're solving. Well, a solution also looks like x equals k because you're finding x. So a solution would be x equals 5, x equals 7, x equals negative 3. The solution would be the answer when you're solving and it's equal to 0. So the only difference between the solution and a 0 is now it's equal to 0. You're actually solving for x. But it's still an x-intercept. The last one, it says it's an x-intercept if it's written as a point. So the graph has the point k, 0. Which is usually what we do when it says find a 0. We write it as an x-intercept because it's a point on the graph. It's on the x-axis. So all of these things mean exactly the same. Especially 3 of the 4, they're written the same way pretty much. So the directions might say find a 0. It could say find an x-intercept. It could say find a solution. You're doing exactly the same thing in all of those. It's just using 3 different terms. But all 3 terms mean the same. So they're synonyms of each other. Factor you're using to find the zeros. So you have to factor in order to find the zeros. So today we're going to look at some graphs that are in factored form. And we're going to do pretty much what was on that sheet, except we're going to try to get a little more specific. So we have 1/4, and then x plus 1 squared, x minus 4. It says use the x-intercepts to graph the polynomial. So if we're using the x-intercepts, the first step says, because blank and blank are zeros of f. What are the zeros of this function? Abby? Right, so we have a 0 by setting this equal to 0. We have a 0 at -1. By setting that one equal to 0, we have a 0 at 4. So those are zeros of the function. Therefore, we're going to plot the point -1, 0, and 4, 0. So I'm going to go down to the graph and plot them right now so that we have those two out of the way. So on your graph, -1, 0, 1, 2, 3, 4, 0. Those are our two x-intercepts, the two zeros, the two solutions, the two factors. Now, there are 2, but technically there would be 3 because this guy here is x squared. And when it's x squared, we really could write that as x plus 1 times x plus 1. And then the x minus 4. So that's how it could be written, but when you have a double factor, usually you're not going to see it written twice. They just combine it together as one. All right, so step 1 is done. That's pretty much what we did on the sheet yesterday. Step 2 says plot points between and beyond the x-intercepts. These points are chosen for you, but if you look at your x-intercepts on your graph, we want at least 1 point beyond it. So I have an x-intercept at -1, so we might as well pick -2. And then we want some points in between them. So like maybe every other one, you could do a 0, you could do a 2, you could do a 3, but we need a couple points in between. So tonight when you're looking, you're going to look at your x-intercept, you're going to pick a point that's beyond it, smaller than it, or bigger than it, and a couple points in between. And then we need another point over here that's beyond or bigger than the 4. So that's how we're getting the points in this table of values. So we have -2 and then 0, 1, 2, 3. That's everything in between it. And then the 5. So using your calculator, see if you can find the y values. So we're taking 1/4 and then -2 plus 1 squared, -2 minus 4. And if you put it in your calculator exactly like this, and I would say you could even put 1/4 as 0.25, and you don't have to worry about the fractions. But use parentheses, plug it in exactly as it's listed with using the -2, and then you'll get an answer for your y. So 0.25, -2 plus 1 squared, -2 minus 4. Tatum, what did you get for -2? Perfect. All right, so try the other ones. Plug in a 0, plug in a 1, 2, 3, and 5. Emma, do you have the value for the other 5 values? What do you have? You said 1/4? And then -3? Okay. Sorry, you're so quiet. Okay. Sorry. The only one I don't have is this guy here. Anybody have anything different from the 1/4? What is it? Rebecca? Just -1 or +1? -1? I don't know, Emma, if the back one, I don't know. Maybe just calculator didn't like you for that. So -1 there. Or Did you say -1? Okay. All right, so now we're going to go and plot those points. So we have a whole bunch of points to plot now. So go down to your graph, plot the points. Remember 9/2 is -4.5. And then the last one is 9. That's going to be off the graph. Let me just put it up here. So it now looks definitely more like a graph that has some shape to it, that we could connect these points. So the third step says determine the end behavior. We'll fill in the blanks here. This is the thought process kind of thinking about here. How many factors does this function have? So technically, how many parentheses are there? Jillian? 3. So there are 3 factors. It says in the constant factor of 1/4. The constant factor is the number in front. So it has a number in front of 1/4. There is a -1/4. Nope, 1/4. So it is a or an blank function. So if the power is 3, it's an odd function with a positive leading coefficient. So it has 3 factors. The number in front is 1/4, so odd and positive means that the y value on the left side of the graph. So if we're on the left side of the graph, what's the y value doing if you're on the left when it's odd and positive? Jillian? It goes down. So the fancy math way to say go down is it goes to -infinity. So x goes to -infinity means the left. It's going down on the left. Julian, if we're on the right side of the graph, because x is going to positive infinity, the y is going right, also to positive infinity, or it's going up. So that would be the mathematical way to write it. You could say the left goes up and the right goes down. Or sorry, the left goes down and the right goes up. So using that information, I'm going to go to my left and make it go down. So the furthest left point should go down. The furthest point on the right should go up. And I guess it should go, I missed my furthest point on the right. The furthest point on the right is way on the right. I'll just connect these guys here. So then it says draw the graph so that it passes through the plotted points and has the appropriate end behavior. So now we have so many points that you can connect them. You get a full, complete graph. It's touching that point at -1. It goes down to the value at +2, and then it continues up. Melanie.
I have a question.
Yeah.
How do you know how many factors you have? How do you know you have 3?
How did you know you have 3?
Yeah.
So because this is squared, there are 2 of them. And then this one here is 1 more. So the squared means you have 2 factors plus a third one. Or we could write the squared one as x plus 1, x plus 1, and then x minus 4. So the number of parentheses would be the number of factors. Other questions? So on Monday, we said the domain, reminded everybody domain was x, the range is y. The domain is how far it stretches left and right. The range is how far it stretches up and down. So what would the domain be? How far is it going to stretch? Can we continue to have any x value? Julia? Right, -infinity to positive infinity. Because it's not going to stop at the x values that we chose. It's going to go on forever. We can get bigger x values and smaller x values. And Julia, the range would be? Right, -infinity to positive infinity. Because it's going down forever, it's going up forever. Questions? So we're going to do another one together. And this one will be similar to how it's worded in your homework, which is why I gave you that little third sheet of paper, because we're going to really follow these steps to kind of help us get a graph. So graph the function by the following process, which we used on the other page, by following the process in the preceding example. So the first step would be to get the x-intercepts, or the zeros, using the factors. So that's step one. So Maddie, what would our x-intercepts be? So if you look at the 3 parentheses and solve the 3 parentheses, what would the x-intercepts be? 2, 0, negative 1, 0, and 1, 0. So those are our 3 x-intercepts. After you find them, graph them. So you have like a physical graph to look at, because the next thing we need to do is to get some extra points. So 2, 0, 1, 0, negative 1, 0. The second step, we're to get some points that are in between and beyond our x-intercepts. So the one on the left is negative 1. That means beyond it would be negative 2. If you want to go even more beyond that, you could go to negative 3. We have in between negative 1 and positive 1, so 0 would be a good number to pick in between there. And then we also need a number in between 1 and 2. What would be a number in between 1 and 2 that you could use? Abby? Yeah, 1.5. Yeah, unfortunately it's a decimal, but you're going to have to get a point in between there so we know what's going on in between there. And then a number beyond 2, well, 3's beyond 2. So once you have your x-intercepts graphed, look at the x-intercepts, pick a point to the left of the last one, in between all of the ones, and then to the right. But you've got to look at those points. So sometimes you might only have 4, sometimes you could have 5, sometimes you could have 6. It just depends on where your points are listed. Now using these points, plug them into your equation that you're given to see if you can find the corresponding y value. And then part C will list the end behavior. Because of the 2 in front, your numbers might be a little large. And that's because there's a multiple of 2 in front. You're not doing it wrong. You're just going to get some big numbers. Bless you. So you should have a negative 24 and then a 4. 1.5, this is like negative 1.25. And then at 3, I think it was it 16? Yes. So 2 of those numbers are pretty darn big. So we can plot the one at 0, 4. 2, 3, 4. We can plot the value in between 1.5, go down to negative 1.25. And then 16 would be way up here. Negative 24 would be somewhere way down there. So the last part, the end behavior, it's odd because there are 3 factors there are 3 x-intercepts, and it's positive. So that means the left goes down and the right goes up. So you can connect your points, and then I wanted to kind of have us look in the calculator. So start from the bottom, try and connect your points smoothly. So that would be our graph. Starting from the left, always start from the lowest point, work your way up. So I'd like you to, after you're done graphing, to go to your calculator into the y equals function of your calculator. And we're going to type in this equation. So wherever you see a parenthesis, type in a parenthesis. So there's the 2 first, and then x minus 2, x plus 1, and x minus 1. So the graph on your screen should look very similar to the graph on your paper. I want us to find, and I'm going to show you how to find, to get this top point and the bottom point, because those would be our max and min values. And we talked about finding max when we did parabolas, or min when we did parabolas, but I just want to kind of go through that with you again. So in your calculator, does anybody remember where the location is in the calculator that it calculates max and min? Julian?
You made the second one to trace.
Yeah, so you're going to hit the second button, and then next to graph is the word trace. Whichever one you want to find first is totally up to you. So if we find the minimum first, I'm going to hit number 3. I need to take the little blinking cursor. If I'm finding the minimum, it needs to be close to the minimum value. So the left bound means it should be on the left side of the lowest point. So right here's my lowest point. It needs to be somewhere to the left. And then you hit the enter button. You get a little arrow then that's pointing. The right bound means the little cursor needs to be past the minimum, slightly to the right. And it doesn't matter where, it's as long as it's to the right. So mine's up here to the right, it's still to the right of the graph. Hit enter. You never do anything for guess. You're just going to hit enter one more time. This gives you the exact minimum of the graph. So we had our minimum at negative 1.5 and negative 1.2, or 1.5 and negative 1.25. The minimum is actually slightly lower than it. So on the graph, we have negative 1.5, we'll say 5. So the minimum would be 1.55 and then negative 1.26. I used 2 decimal places. Really close to our minimum that we had, but not exactly the lowest point. So we got close to it, but we didn't get an exact value. If you want to get the maximum, that point up here, you go back to second trace. You have to do it a second time. For every curve, you have to find a value. So if there were 4 curves, I'd have to do this 4 times. But I want to get the maximum point this time, not the minimum. So left bound, go to where your maximum is, go slightly to the left of it. So start at where your highest point is, go to the left, hit enter. Go to the right of the peak of the graph, hit enter, and then let it do its work here. So negative 0.22 and it looks like 4.23 would be our maximum of the graph. Which again is close to what we have. We have it 0.4, so it's close, but it's not quite on that minimum or the maximum. Questions? So tomorrow we're going to talk about a couple more vocab terms. We'll use the calculator a little more tomorrow. And then as I said, we have a word problem to look at tomorrow.
For any curve above the x-axis, you can do that as a
So pretty much any curve that looks like a mountain, you do a max. Any curve that looks like a valley, you do a min. So it has to look like a max versus a valley. Again, follow the little directions on your homework. Anybody interested in doing 5 or 8 for tomorrow? Showing a graph, doing some work, 5 or 8 for a presentation problem. Melanie, you'll show 5. Abby or Gabby, you'll do 8 for me. Thank you. Have an awesome day.